Hello guys, this is Prime Concept. We have another problem to solve under electrostatics. Now we have two charges are located on the positive x-axis. Positive x-axis. So if I should draw, here's my positive x-axis. So it means that this point is my origin, right? So that anything backward becomes negative. So this is our origin. Let me just denote it like this. So it means from here upward is positive and this place is negative. So we are dealing with just the positive. So two charges are located on the positive x-axis of a coordinate system. Charge Q1 equals this is 2 cm from the origin. So if this is our origin, so we're going to say from here to here, let it be 2 cm. So this is where we have Q1. And this distance we have here is 2 cm. This distance is 2 cm. And they also said from the origin, and charge Q2, which is this, is 4 cm from the origin. So still, this is our origin. So it means that if we say this is where Q2 is, it simply means that the distance from here down to this point is going to be what? You are correct. It's going to be 4 centimeter because they told us 4 cm from the origin. So this is our diagram. And the question says, what is the magnitude of the total force exerted by these two charges on a charge Q3 located at the origin? So we want to find the magnitude of the force that Q1 and Q2 would exert on a third charge Q3. So since Q1 and Q2 are exerting a force on Q3, it simply means that Q3 is our test charge in this case. So and Q3 is located at the origin. So this is where Q3 is. So this is our Q3 at the origin. So this is our solution diagram. I'm going to bring out my parameters. So we have Q1, the value for Q1 is 2 times 10 to the power minus 9 Coulomb. Q2 is 3 times 10 to the power minus 9 Coulomb. Then Q3 is 5 times 10 to the power minus 9 Coulomb. So remember, they are all positive. Now I'm going to rub so I can have space to solve. So now notice that the distance they gave us, they are all in centimeters. So don't always forget to work with SI unit. Charge is in Coulomb, so your distance has to be in meters. So the first thing I want to do, and the distance between 1 and 3, I'm going to call it, this is R13, 1 and 3 is 2 cm. So and 2 cm is same thing as 0.02 meters. How did I get that? 2 divided by 100 would give us 0.02. And the next I want to get is between 2 and 3. So which I'm going to call R23, which is 4 divided by 100, right? 4 divided by 100 will give us 0.04 meters. So these are the distances we have. Now the first thing, remember, Q3 is our test charge. That is the charge that is receiving the force. Q1 is our source. Q2 is also our source. So the first thing we want to do is to find the magnitude of force between Q1 and Q3. So let's do that. I'm going to call it F13, which is KQ1 Q3 by R13 squared. So what do I have? K is 9 times 10 to the power 9. Q1, 2 times 10 to the power minus 9. Q3, 5 times 10 to the power minus 9. Divided by R13, which is 0.02 squared. So if you punch this, let me quickly do that. So I have 2.25 times 10 to the power minus 4 Newton. So that is the value. And the next thing I want to do is to find Q2 and Q3. So I'm going to call that F23, which is KQ2 Q3 by R23 squared. So if I solve this, I would have 9 times 10 to the power 9 Q2, 3 times 10 to the power minus 9, then Q3, 5 times 10 to the power minus 9, divided by this distance now is 0.04. Don't always forget to square your distance, right? Now if I punch this also, I would have 0.844 times 10 to the power minus 4. So that is the force, right? Now, since I've gotten F13 and I've also gotten F23, what is the next thing I want to do? The next thing to do is to get your net force. And before you get your net force, you need to find the direction of these forces. Now, let's do the first one. Between this and this, notice they are both positive, right? And when you have positive, you're going to have a repulsive force. And remember, repulsive forces point away from the source. So the force here is going to be in this direction, away from the source. So this is my F13 pointing away, right? And then you know anything pointing backwards is pointing where? You are correct, negative. So this is negative. And the next direction I want to find is direction for F23. Now this is my 3 and this is my 2, which is still positive. So the force between Q3 and Q2 is a repulsive force. Repulsive will still point where? You are correct, away from the source. So this is our source. So it's going to point like this. So this is my F23, away from this source. Now where is it pointing? Which direction? You are correct. It's pointing towards the negative. So F23 is also going to be what? Negative. Now the next thing I want to do is to find my net force. So my net force is going to be the combination, the algebraic summation of both of them. So which is going to be minus F13 minus F23. So this is my net force, right? So what do I do from here? I'm going to have, minus 2.25 times 10 to the power minus 4 minus 0.844 times 10 to the power minus 4. So if I solve this, I would have minus 3.094 times 10 to the power minus 4 Newton. So what it simply means is that the magnitude of my force is just 3.094 times 10 to the power minus 4 Newton. That is the magnitude. Then the negative sign tells us that the force is pointing backwards. It's pointing towards the test charge, Q3. That is what negative tells us. It's pointing backwards towards the test charge, Q3. So that is the direction. I believe this concept is very clear to you. I will solve more examples. So do follow my videos, watch my videos, and subscribe to my channel, right? Thanks for watching. Remember, this is Prime Concepts.